Let's talk about Pythagorean identities. Let's see why sine square of a theta plus cosine square of a theta is actually equal to 1. Remember that sine square theta is same thing as sine of some angle and then taking square of that value. These two mean the same thing. So is cosine of some kind of angle and then you square it. It's the same meaning. Okay, so let's just see why this is true. Okay, in order to do this, let's draw a triangle. Okay, you could draw a unit circle, but I'm not going to do that right now. So let's draw a triangle that's in the first quadrant here. Let's make a right triangle. Okay, let me see. And then we make that 90-degree angle right there. And then we're going to call that angle theta. Let's just assume this hypotenuse is 1. Okay, so it's just like having a unit circle, but I don't want to draw that unit circle right now. So we do know that this from here to here is some kind of x value in terms of length. So that length must be some kind of y. So that point right there has x comma y value in it. Okay, let's not worry about that point right now. We also know that sine of angle is equal to opposite over hypotenuse. And so that opposite, if that's the angle right there, opposite is y over hypotenuse is 1, because we set 1 as an hypotenuse. And then cosine of that angle must be adjacent side over hypotenuse, which is adjacent to that angle is x over 1. Well, y over 1 is just y, and so is x over 1 just x. And if you look at this right triangle, we have a Pythagorean theorem that goes one of the leg of a right triangle square plus the other leg square must be the hypotenuse square, okay, which is 1. 1 square is 1. So x square, but then instead of x square now, I'm just going to plug in cosine. Cosine angle, the whole thing square, because that's what x is equal to. Plus y, instead of y, I'm going to plug in sine of that angle. So sine theta, the whole thing square, must be 1. That's why we have this Pythagorean identity. Okay? Now, let's derive other two forms of Pythagorean identity. Let me get rid of this. And then let's divide all the terms by, what do we want to divide by first? Let's divide everything by cosine square. Cosine square. Everything cosine square. Okay. Then we know that sine theta over cosine theta is actually tangent theta. Okay. Then sine square theta over cosine square must be tangent square theta. And then cosine square over cosine square is just going to be 1 because same top, same bottom. Should equal to 1 over cosine square is actually cosecant square theta. So by dividing all the terms by cosine square theta, we have another identity. You should memorize this or at least know how to derive it. But for the other one, I'm just going to divide everything in this time, everything by sine square theta. So we do the same thing except we're dividing by sine square theta this time. Then you're going to get, well, sine square over sine square is just 1. And then cosine over sine. Remember, sine over cosine was tangent, but then cosine of angle divided by sine of angle. If these are angle they're same, then we're going to have a cotangent angle because tangent and cotangent are reciprocal to each other. So cosine square over sine square is going to be cotangent square of an angle. Should equal to 1 over sine is cosecant, but it's sine square. So we're going to put cosecant square theta. So that's the third Pythagorean theorem or Pythagorean identity in trig. But you don't have to memorize it as long as you know how to derive it from number one. So if you just know number one and how to use it, you'll be fine.